close your eyes for a moment. Take a breath. Now think about the last time you were in a crowd. Maybe it was a concert, a sporting event, a busy shopping centre, or just walking through a city street during rush hour. Think about all those faces, all those individual lives, all those separate stories walking past you, around you, through you like rivers of humanity flowing in every direction. Now multiply that crowd by 1,000,000, then multiply it again and again. Keep going until you reach a number so large it stops meaning anything at all. 8 billion. That's how many humans are alive on Earth right now. 8 billion hearts beating. 8 billion minds thinking. 8 billion stories unfolding simultaneously across every continent, every country, every city, every village, every remote corner of this planet we call home. 8 billion. If you counted one person per second, it would take you over 253 years to count everyone alive today. You'd need to count continuously, without sleeping, without eating, without pausing for breath, for more than 2.5 centuries just to acknowledge each individual human existence. We are everywhere. We have spread across the face of the earth like no species before us. We live in frozen Arctic settlements and scorching desert cities. We have built homes in the highest mountains and the lowest valleys. We farm the plains, fish the oceans, mine the depths. We have even sent some of ourselves beyond the atmosphere itself, floating in metal cans among the stars, looking down at the blue marble that birthed our species. 8 billion seems inevitable now. It seems like humanity was always destined to dominate this planet. When you look at a city skyline or watch the lights of civilization spread across the night side of Earth from space, it feels like this was always meant to be. Humans everywhere. Humans forever. Humans triumphant. But here's where the story takes a turn. Here's where everything you think you know about human history gets flipped upside down and shaken until the coins fall out of its pockets. If you're using this to fall asleep, by the way, that's exactly why I made it. So settle in, get comfortable, let your breathing slow, and let me tell you about the time we almost didn't make it. Let me tell you about the 280, because roughly 900,000 years ago, give or take a few tens of thousands of years, something happened. Something catastrophic. Something so devastating that it reduced the entire human population on Earth to approximately 1,280 breeding individuals. Not 1,280 million, not 1,280,000, just 1,280 people, total, everywhere on the entire planet. Think about that number for a moment. Let it settle into your mind like a stone sinking into still water. 1,280 people is smaller than most high schools. It's smaller than many apartment buildings. It's the population of a tiny village, the kind of place where everyone knows everyone else's name, where there are no strangers, where every face is familiar. You could fit 1,280 people into a single large airplane. You could seat them all in a small theatre. You could gather every single human being alive on Earth at that moment into a single room and still have space left over for the catering. That's not a civilization. That's not even a town. That's a bottleneck. That's a species standing at the edge of extinction, one bad season away from disappearing forever, one epidemic away from becoming nothing but fossils that future intelligent species might eventually discover and puzzle over. And it didn't last for a year or a decade or even a century. This population bottleneck, this near-extinction event, lasted for approximately 117,000 years. Let that number wash over you. 117,000 years. For context, all of recorded human history, every empire that rose and fell, every war fought, every book written, every song sung, every monument built, covers about 5,000 years. The bottleneck lasted more than 20 times, longer than all of recorded history combined. For 117,000 years, your ancestors lived on the razor's edge between existence and oblivion. For 117,000 years, they struggled and suffered and held on by their fingernails, while the world tried its very best to wipe them out completely. For 117,000 years, the entire future of humanity, all 8 billion of us who exist today, every person you've ever met or loved or passed on the street, depended on this tiny, desperate, impossibly brave group of survivors who refused to give up. Every single person alive today is descended from those 1,280 survivors. Every face in every crowd, every name in every phone book, every child born tonight in every hospital in every country on Earth. All of us carry DNA that traces back to that small group of ancient humans who somehow, against odds that should have been impossible, made it through. This isn't mythology. This isn't legend or folklore or religious narrative. This is science. This is what geneticists found when they learned to read the human genome like a history book written in molecules. This is the story your own DNA is telling, if only you know how to listen. Tonight, I'm going to tell you that story. We're going to go back almost 1 million years, to a world you wouldn't recognize, to a planet in crisis, to the moment when humanity's flame burned so low it nearly went out entirely. And we're going to follow those survivors through 117,000 years of hardship, through ice ages and droughts and predators and starvation, until finally, impossibly, they emerged on the other side. This is the story of how 980 people became 8 billion. This is the story of your ancestors. This is your story, and it begins with a mystery hidden in your blood. Chapter 1. The Genetic Detectives. How scientists discovered we almost went extinct. The discovery didn't happen in some ancient cave or dusty archaeological dig. It happened in a laboratory under fluorescent lights surrounded by humming machines and the quiet concentration of scientists staring at computer screens. And it started with a puzzle that made no sense. In the 1980s, geneticists began developing techniques to read DNA. Not just identify it, like in a crime scene investigation, but actually read it. Trace the individual letters of the genetic code that makes you who you are. And as they got better at reading DNA, they started noticing something strange. Humans are genetically boring. I know that sounds like an insult, but in scientific terms it's genuinely remarkable. When you compare the DNA of different human populations, a person from Iceland versus someone from Japan, an Aboriginal Australian versus a Nigerian, a Brazilian versus a Tibetan, the differences are tiny, vanishingly small, almost identical. This isn't what you'd expect from a species that has spread across every continent and adapted to every environment, from tropical rainforest to frozen tundra. When you look at other widely distributed species, you find enormous genetic variation between populations. Animals that live in different regions, facing different challenges, develop different genetic solutions. Their DNA diverges, their populations become distinct, but not humans. Despite our global distribution, despite our superficial differences in appearance, despite thousands of years of geographic separation, we're all remarkably, suspiciously similar at the genetic level. Here's the comparison that really made scientists scratch their heads. Take 2 chimpanzees from opposite sides of Africa. These chimps live in scattered populations across a much smaller geographic range than humans. They haven't spread across the entire planet. They're not adapted to different climates. And yet, 2 random chimps are more genetically different from each other than any 2 humans on Earth. You and someone living on the opposite side of the planet are more genetically similar than 2 chimps living a few 100 miles apart. That's not normal. That's not how evolution usually works. That's the fingerprint of something dramatic, something catastrophic. The first clue came from mitochondrial DNA. Mitochondria are tiny structures inside your cells that produce energy, and they have their own DNA separate from the DNA in your cell nucleus. This mitochondrial DNA is special because it passes only from mothers to children. When you were conceived, you inherited your mitochondria from your mother's egg cell, not from your father's sperm, and she inherited hers from her mother, who inherited hers from her mother, and so on back through time. By analysing the differences in mitochondrial DNA between people around the world and counting the mutations that had accumulated, geneticists could work backward through time. They could build a family tree that stretched back through hundreds of thousands of years. And when they traced all those maternal lines backward, they converged. They all pointed to a single woman. The media called her Mitochondrial Eve, which is a bit misleading. She wasn't the only woman alive at the time, and she certainly wasn't the biblical Eve. But she was the only woman from that era whose maternal line survived to the present day. Every other woman's daughters eventually had no daughters of their own, or those lines died out for other reasons. Only this one woman's maternal descendants made it all the way to today. Mitochondrial Eve lived in Africa sometime between 150,000 and 200,000 years ago. That dating has been refined over the years as techniques improved, but the basic finding stood. All human mitochondrial DNA traces back to one African woman who lived relatively recently in evolutionary terms. Then came the Y chromosome studies. The Y chromosome is the male equivalent of mitochondrial DNA for tracing ancestry. It passes from fathers to sons, relatively unchanged except for occasional mutations. When geneticists traced Y chromosomes backward, they found a similar pattern. All human Y chromosomes converge on a single man, Y chromosomal Adam, who lived somewhere between 200,000 and 300,000 years ago. Again, he wasn't the only man alive, but he was the only one whose paternal line survived unbroken to the present. These discoveries told scientists something profound. At some point in our past, human population had crashed so severely that only a tiny fraction of genetic lineages survived. Most family lines simply ended. Most people who lived during that era left no descendants at all, or their descendants eventually died out without continuing the line. This is what scientists call a genetic bottleneck. When a population crashes, it's like squeezing everything through a narrow tube. Only some of what was there before makes it through. Genetic diversity gets lost, variation disappears, and the survivors, no matter how much they later multiply, carry only a fraction of the original genetic diversity. But mitochondrial and Y chromosome DNA only tell part of the story. They track single lineages, mother to daughter, father to son. To understand the full picture, scientists needed to analyze the entire genome, all the DNA that makes us who we are. And when they did, starting in the early 2000s with increasingly sophisticated genetic sequencing technology, the evidence became overwhelming. Humans had gone through not just one bottleneck, but possibly several, and one of them was devastating. The genetic signatures are everywhere once you know how to look. One of the clearest markers is something called linkage disequilibrium. In normal populations, genetic variants get shuffled and recombined every generation through sexual reproduction. Over time, this creates a random distribution of traits. But in bottlenecked populations, this shuffling process gets interrupted. Genetic variants that happen to be present in the survivors stay linked together for thousands of generations, creating patterns that persist. To the present day, human DNA is full of these patterns, fossil evidence of ancient population crashes written in our genes. Another signature is in our mutation load. Every human carries dozens of slightly harmful genetic mutations. In large populations, natural selection efficiently removes these mutations over time. But in small populations, random chance becomes more important than selection. Harmful mutations can spread just because they happen to be in the survivors, not because they provide any advantage. The number and distribution of harmful mutations in human DNA suggests we spent a very long time, as a very small population, small enough that random genetic drift overwhelmed natural selection. By the 2010s, geneticists had developed sophisticated computational models that could analyze these signatures and estimate ancient population sizes. Different research groups using different methods kept arriving at similar conclusions. Sometime in the deep past, the effective breeding population of humans dropped to somewhere between 1,000 and 10,000 individuals. Some studies suggested even smaller numbers, but the precise timing and severity remained debated. Was it a single sharp crash? A prolonged period of low population? Multiple separate bottlenecks? The data could fit several scenarios. Then, in 2023, a team of researchers published a study that would change everything. Using a new analytical method called FITCOL, which stands for Fast Infinitesimal Time Coalescent, they analysed genetic data from over 3,000 people across 10 African and 40 non-African populations. This technique could detect population size changes with unprecedented precision, reading the genetic record like tree rings, each layer revealing what the population was doing thousands of years earlier. What they found was stunning. Between 930,000 and 813,000 years ago, the ancestral human population crashed to approximately 1,280 breeding individuals, not 1,280 total people, breeding individuals. The actual population might have been somewhat larger, but the number of people successfully reproducing was about 1,280. This population bottleneck persisted for approximately 117,000 years. For more than 100 millennia, humanity teetered on the edge of extinction, maintaining a breeding population barely larger than a small village. The paper, published in the journal Science, sent shockwaves through the scientific community. Here was genetic evidence for a near-extinction event that corresponded to a known gap in the fossil record. the period between 900,000 and 650,000 years ago, when human fossils become mysteriously scarce. Not everyone accepted the findings immediately, of course. That's how science works. Some researchers questioned the methods, others pointed out alternative explanations. The debate continues, but the core finding, that human populations crashed to dangerously low levels at some point in our distant past, is supported by multiple, independent lines of evidence. We were always a species that almost wasn't. Every person alive today carries the genetic scars of that ancient near-extinction. We are the descendants of champions, survivors of a 117,000-year ordeal that should have ended our species entirely. But here's the question that haunted scientists after these discoveries. If human populations crashed that severely for that long, what caused it? What kind of catastrophe could reduce a thriving species to barely more than 1,000 breeding individuals for over 100,000 years? The answer, it turns out, was the planet itself. Word count check. Approximately 3,150 words. Chapter 2. The World That Tried to Kill Us. 900,000 years ago, when Earth became hostile. To understand what happened to your ancestors, you need to understand the world they lived in. And 900,000 years ago, that world was nothing like the one you know. Close your eyes and let the present dissolve. Let the cities fade, the roads disappear, the farms and fields give way to something older. Let the continents themselves shift slightly, returning to positions they held almost 1 million years ago. You're going back now, back through ice ages and warm periods, back through the rise and fall of countless species, back to a time when your ancestors weren't yet recognizably human, but were on their way. The Earth 900,000 years ago was in the grip of dramatic climate changes. This was the Pleistocene epoch, the age of ice ages, when massive glaciers advanced and retreated across the northern continents in cycles that lasted tens of thousands of years. But the cycles weren't the biggest problem. The problem was that around 900,000 years ago, the nature of these cycles changed. Before this time, Ice Age cycles followed a roughly 41,000-year rhythm, driven by changes in Earth's axial tilt. But around 900,000 years ago, something shifted. The cycles lengthened to approximately 100,000 years and became much more extreme. The cold periods became colder, the ice sheets grew larger, the climate swings became more violent and unpredictable. Scientists call this the mid-Pleistocene transition, and it was devastating for life on Earth. But we're getting ahead of ourselves. Let's focus on where your ancestors were living during this crisis: Africa. At this time, the human lineage was represented by a species or group of species that scientists are still arguing about. They might have been late Homo erectus, early Homo heidelbergensis, or something we haven't quite classified yet. These weren't modern humans. Homo sapiens wouldn't appear for another 600,000 years or so. But they were definitely human. They walked upright. They made stone tools. They used fire, at least some of them. They lived in social groups and cared for their young. They were your ancestors, even if they wouldn't recognize you as kin. And 900,000 years ago, their world was falling apart. The climate changes that were transforming the Northern Hemisphere had profound effects on Africa. The monsoon patterns that brought life-giving rains began to shift and fail. Lakes that had sustained populations for thousands of years started to dry up. Rivers that had been reliable water sources became seasonal trickles, then disappeared entirely. The forests that had covered much of eastern Africa began to die back. Trees that had provided food, shelter and resources retreated to scattered patches, separated by expanding grasslands and increasingly by desert. For your ancestors, who had evolved in a world of mixed woodland and savanna, this was catastrophic. The environments they knew, the resources they depended on, the strategies that had sustained their ancestors for millions of years, all of it was disappearing. Picture yourself there. You wake before dawn in a landscape that your grandparents would barely recognize. The river where your mother learned to fish as a child has been dry for years now. The fruit trees that used to grow on the hillside died in the drought when you were young. Every day you and your small group have to travel farther to find water, farther to find food, farther from the places that used to mean safety. And you're not alone in your desperation. Other groups are facing the same crisis. Competition for dwindling resources is fierce. The animals you used to hunt have migrated to areas you've never explored. The plants you used to gather are gone. Now imagine this isn't a bad year. It's not even a bad decade. This is the new normal. This is how the world is now. And it's going to stay this way for longer than any human mind can comprehend. The 2023 study that identified the bottleneck suggests it coincided with a severe reduction in genetic diversity among African populations, while non-African populations show signs of this bottleneck in their ancestry as well, meaning the survivors were the common ancestors of all humans who later left Africa. This means the bottleneck didn't just affect one isolated group, it affected the entire ancestral human population. Wherever your ancestors were living at this time, and the best evidence suggests they were concentrated in Africa, they were all caught in the same crisis. Some researchers think the survivors clustered in specific refuge areas where conditions remained barely tolerable. Coastal regions where marine resources provided food security, highland areas where temperatures were cooler and water sources more reliable, Rift Valley lakes that maintained enough water to support life even during the worst droughts. The South African coast is one proposed refuge. Archaeological evidence shows human occupation of coastal caves during this period, with shells and fish bones indicating a diet based heavily on marine resources. The cold Benguela current that flows along this coast creates upwelling zones rich in nutrients, supporting abundant sea life even when the land is barren. Another proposed refuge is the Ethiopian highlands, where higher elevation meant more rainfall and cooler temperatures. Lake basins in the Rift Valley might have provided oases of habitability, surrounded by increasingly hostile terrain. But these refugees were small, they could only support limited populations, and getting to them meant crossing increasingly dangerous landscapes, drought-stricken, resource-poor, prowled by predators who were just as desperate and hungry as the humans. The population collapse wasn't sudden. It was a slow squeeze lasting tens of thousands of years. Each generation was smaller than the last. Each group was more isolated, more vulnerable, more precarious. Think about what that means for a moment. Every generation knowing that things were worse than they used to be. Children hearing stories from elders about better times that were already fading into legend. Families splitting apart to search for resources, never seeing each other again. Groups that had traded and intermarried for. Countless generations losing contact as the distances between habitable zones grew too great to cross. The archaeological record from this period is sparse, which makes sense. Fewer people means fewer artifacts. But what we do find shows evidence of severe stress. Tool technologies that had been advancing for millions of years stagnate or even regress in quality. Signs of processing whatever food could be found, however marginal. Evidence of mobility, of people moving constantly in search of anything that could sustain life. And then there are the absences, the fossils we don't find, the sites that are mysteriously empty during this period, the gaps in the record where there should be evidence of human occupation but there's nothing at all. Those gaps are the ghosts of groups that didn't make it, people who set out from one refuge toward another and never arrived, populations that dwindled until the last survivor died alone, entire lineages that ended not with a bang but with a whimper, somewhere in the African wilderness, leaving no descendants and no trace. For 117,000 years, this was life for your ancestors. Not a dramatic apocalypse, but a slow, grinding attrition. A world that was constantly taking away, constantly demanding more than it gave, constantly pushing the survivors toward that final edge beyond which there would be no return. Ndasndureti breeding individuals. That's what was left. That's what stood between humanity and extinction. That's what somehow, impossibly, held on. But how? How do you survive for 117,000 years with a population that small? How do you maintain enough genetic diversity, enough knowledge, enough social cohesion to keep going, generation after generation when everything is working against you? The answer lies in how your ancestors lived. And it wasn't just about being tough. It was about something much more important. It was about being human. Word count check. Approximately 5,200 words, cumulative to mainly 50 words. Chapter 3. Life on the Edge. What survival looked like for 117,000 years. Let's go there. Let's leave the comfortable present behind entirely and sink into the deep past. Let your breathing slow. Let the tension in your shoulders release. And let me take you back to a morning almost 1,000,000 years ago, to the life of someone who might have been your direct ancestor. You wake before dawn in a shallow cave on the southern coast of Africa. The air is cool, but not cold. Outside, you can hear the rhythm of waves breaking against rocks, a sound that has become the heartbeat of your existence. Your group numbers about 25 people, 3 extended families bound together by blood and by necessity. There's your immediate family, your partner, who still sleeps beside you, and your 3 children who survived past infancy. That survival makes you lucky. Your brother's family sleeps nearby, and your mother, who at perhaps 40 years old is considered ancient, the eldest person anyone in your group has ever known. She's a living library of knowledge that no one can afford to lose. You don't live in this cave permanently. Your group moves seasonally between 3 or 4 sites within a territory of maybe 20 square miles. Each location offers different resources at different times. One cave sits near a freshwater spring that never quite dries up, even in the worst droughts. Another overlooks a rocky coastline where the tide pools teem with shellfish. A third provides access to a river valley where wild tubers grow in the rainy season, if there is a rainy season that year. This mobility is what keeps you alive. Put 25 people in one spot permanently, and they'd exhaust the local resources within months. But keep moving in a carefully planned circuit. Let each location recover while you exploit the others, and you can make it work. Barely. Your morning starts with fire management. Keeping fire going is a full-time obsession. You don't have reliable methods to start fire. From scratch. Not yet, those techniques are still tens of thousands of years in the future. So you maintain embers constantly, banking them at night in ash and dried dung, nurturing them back to flame each morning. Losing your fire means days or weeks of travelling to another group to beg for embers. It means cold nights, raw food, and vulnerability to predators. It means potential death. So you feed the fire carefully, efficiently. Every piece of wood is precious because the landscape is increasingly barren. You've learned to burn dried animal dung when wood is scarce. You've learned to use bone as fuel. Nothing is wasted. Then comes foraging. This isn't a casual walk through nature. This is systematic, learned, strategic exploitation of every calorie your territory offers. Your mother knows the location of every tuber patch within a day's walk. She knows which roots are edible and which will kill you. She knows where to find the grubs that live under the bark of dead trees, each one a precious packet of fat and protein. She knows the seasonal movements of small game, the nesting sites of ground birds, the locations of beehives. This knowledge isn't written down. It can't be. It exists only in the memories of the oldest members of your group passed down through demonstration and repetition. Watch how grandmother digs for this root. See the way she tests the soil moisture with her fingers first. Notice how she marks the location so she can return next season without depleting the patch entirely. One mistake, one forgotten lesson, could mean starvation. The women and children do most of the gathering, not because of some primitive gender role exactly, but because it's efficient. Gathering requires intimate local knowledge, patience, the ability to process information about hundreds of different plant species. It also allows you to keep the children close, teaching them while they work. The calories you bring in are reliable, predictable, the foundation of your group's survival. The men typically focus on hunting, though everyone does everything when necessary. But hunting during the bottleneck isn't the dramatic big game stalking you might imagine. The vast herds that once roamed Africa are gone, died out or migrated to regions you can't reach. What's left are small animals, opportunistic targets. You're not apex predators, you're survivors. You hunt small antelope when you can corner them in ravines. You trap rock hyrax, rabbit-sized mammals that den in cliff faces. You steal kills from smaller predators when the opportunity arises, using your numbers and your fire-hardened spears to chase off wild cats or jackals. Sometimes you're successful, often you're not. The hunting provides crucial protein and fat, but it's irregular. Feast or famine. But there's one resource that's changed everything for your particular group: the ocean. Your cave overlooks a rocky stretch of coastline where the cold Benguela current upwells, bringing nutrients that support an explosion of marine life. The tide pools here are reliable in a way terrestrial resources aren't. Twice a day the ocean delivers food to you: limpets clinging to rocks, mussels in dense beds, sea snails, occasionally octopus trapped in shallow pools at low tide, even seaweed rich in iodine and other micronutrients. This is why your group has survived when others haven't. The coast provides a buffer against the worst of the inland droughts. When the terrestrial resources fail completely, when the tubers won't grow and the game disappears, you can always fall back on the tide pools. It's not glamorous food. Shellfish are small, time-consuming to gather, tedious to process, but they're there, reliable, constant. Archaeological sites along the South African coast from this period show massive shell middens, piles of discarded shells meters deep. Evidence that humans huddled along these coastlines for thousands of years, eating unglamorous seafood while waiting for the world inland to become livable again. Your ancestors were among them. The daily routine of shellfish gathering becomes almost meditative. You wade into tide pools at low tide, feeling with your feet for the distinctive shape of mussels. You pry limpets from rocks with a stone wedge, the same motion thousands of times until your fingers ache. Back at the cave, you roast them over the fire until the shells open. The meat inside is small, but it adds up. 100 shellfish, 200, enough to fill bellies, keep children growing, maintain the strength needed to survive another day. But survival is about more than just calories. It's about maintaining the social bonds that keep your group functioning. 25 people living in close quarters for 117,000 years, generation after generation. That's a pressure cooker for conflict, arguments over food distribution, disagreements about when to move camp, tensions over mating, childcare, status within the group. Your people have developed mechanisms to manage this. Elaborate food-sharing customs that ensure everyone gets fed. Not equally, necessarily, but predictably. The best hunters get larger portions, but they're also expected to share. Children and pregnant women get priority. The elderly, like your mother, earn their share through their knowledge, their teaching, their role as living repositories of survival information. You have rituals, too. Simple ones, but important. Gathering around the fire at night to share stories. Not grand epics yet, just accounts of the day's foraging, news from other groups encountered during seasonal movements, warnings about dangerous animals or places where water was found. These fireside gatherings serve multiple purposes. They distribute vital survival information. They reinforce group bonds. They teach children the knowledge they'll need to survive. And there's art. Or something like it. Ochre pigments ground and mixed with fat, used to decorate bodies during significant occasions, a successful hunt, a child's first gathering expedition, perhaps funerary practices for the dead, though evidence is scarce. These aren't elaborate rituals, but they're the beginnings of symbolic thinking, the human impulse to mark meaningful moments, to create meaning in a world that seems determined to destroy you. The psychological burden of this existence is almost impossible for us to imagine. You watch children die regularly. Infant mortality is probably 40 to 50%. Half of all children don't survive to age 5. Starvation, disease, accidents, predation. You lose siblings, cousins, friends. Some seasons are better than others, but bad seasons are brutally bad. Watching your child starve slowly because there simply isn't enough food, making impossible choices about who gets the limited calories available. Yet you persist. Something in the human spirit, some fundamental stubborn refusal to give up keeps you going. Maybe it's the fire, that tangible symbol that you can shape your environment, that you're not helpless. Maybe it's the knowledge your mother shares, proof that others have survived before and so can you. Maybe it's simply the biological imperative, the deep genetic drive to survive and reproduce no matter what. Other groups are out there. You know this. Occasionally you encounter them during seasonal movements, sometimes peacefully, trading information about water sources or food locations, possibly exchanging marriage partners, though the demographics of near extinction make this complicated. With so few humans total, every group needs to maintain connections with others to avoid inbreeding, but encounters can also be tense. When resources are desperately scarce, neighbouring groups become competitors, threats. There's archaeological evidence of violence from this period, skeletal remains showing healed fractures consistent with interpersonal conflict. Not war exactly, but certainly disputes that turned physical. Territories are defended, intrusions are resisted. Despite the hardship, despite the constant proximity to death, life has moments of something almost like normalcy. Children play in tide pools, learning to forage while chasing crabs. Adults laugh at shared jokes, take pleasure in a particularly successful gathering day. Couples bond over shared survival tasks. Your mother tells stories while showing your daughter which plants are safe. This is life on the edge. Not heroic, not dramatic in the moment, just the grinding, relentless work of survival, day after day, generation after generation, for 117,000 years. You don't know you're part of a genetic bottleneck. You don't know your descendants will inherit the Earth. You just know that today you found enough shellfish to feed your family, that the fire is still burning, that everyone survived another night, and tomorrow you'll do it all again. Word count check. Approximately 3,800 words, cumulative 12,850 words. Chapter 4. The Ties That Bind. How Cooperation Saved Humanity. Here's what should have killed your ancestors. Not the drought, not the predators, not even the climate catastrophe that lasted 117,000 years. What should have killed them was math. A population of 280 breeding individuals is below what biologists call the minimum viable population for most large mammals. Below a certain population threshold, species tend to spiral toward extinction regardless of other factors. Genetic diversity collapses. Inbreeding depression accumulates harmful mutations. Random catastrophes can wipe out significant portions of the remaining population in single events. By all the rules of population genetics, your ancestors should have died out. The math said they were doomed. The statistics predicted extinction. But here's what the math didn't account for. Humans aren't just animals. Your ancestors had something that no other species possessed to the same degree. They had culture. They had the ability to pass information from one generation to the next through teaching and learning, not just genetics. They had language, or at least the beginnings of it. They had social structures that could maintain cooperation even under extreme stress. And most importantly, they had each other. Let me tell you what cooperation meant during the bottleneck. It wasn't an abstract virtue or a nice-to-have social arrangement. It was the difference between life and death, every single day, for 117,000 years. Start with food sharing. In any human group, some individuals are better at finding food than others. Some are better hunters. Some are better gatherers. Some are just luckier on any given day. In a world where calories are scarce and unreliable, this creates a problem. If everyone keeps what they find, the unlucky starve while the lucky eat. Over time, this leads to population collapse as more and more individuals fail to get enough nutrition to survive and reproduce. But if food is shared, if the successful hunter distributes meat to everyone in the group, if the lucky gatherer brings her tubers back to feed others, then the risk is spread. Today you might find nothing, but someone else will share with you. Tomorrow the situation might be reversed. Over time, everyone survives periods that would have killed them if they were alone. This isn't just theory. Studies of modern hunter-gatherer societies show exactly this pattern. Food sharing is universal among foraging peoples, and it's not charity, it's survival strategy. The mathematical models show that food sharing dramatically increases the survival probability for small groups living in unpredictable environments. Your ancestors figured this out. Not consciously, perhaps. They didn't sit down and calculate optimal sharing strategies. But the groups that shared food survived, and the groups that didn't share died out. Evolution selected for sharing behavior. But food sharing requires something else. Trust. You're not going to share your hard-won calories with someone you think will cheat you. You need to know that when you're the unlucky one tomorrow, others will share with you. You need to believe that the social contract will hold. This is where human social cognition becomes crucial. Your ancestors developed the ability to remember who was trustworthy and who wasn't. They developed ways to punish cheaters, social sanctions, exclusion from sharing networks, loss of status. They created reputation systems that tracked individual behavior over time. These cognitive abilities didn't evolve during the bottleneck, of course. They had been developing for millions of years, but the bottleneck stress-tested them to the maximum. Groups with strong sharing norms and effective cheater detection survived. Groups without these cultural adaptations died out. Now consider childcare. Human children are helpless for far longer than the offspring of any other species. A baby chimp can cling to its mother from birth. A human infant can't even hold up its own head. Human children need years of care and teaching before they can survive independently. This creates an enormous burden, especially for mothers. A woman nursing an infant while also trying to gather enough food to survive, while also watching for predators, while also keeping older children safe. It's nearly impossible without help. Enter alloparenting. The technical term for what your ancestors were doing, cooperative childcare. Not just mothers raising children, but grandmothers, aunts, older siblings, and sometimes even unrelated group members all contributing to child rearing. The grandmother hypothesis suggests that human longevity evolved partly because post-reproductive women could contribute so much to their grandchildren's survival. A grandmother who helps care for grandchildren ensures more of her genes make it to the next generation, even though she's no longer reproducing herself. During the bottleneck, this cooperative, childcare would have been essential. With so few people, every child that survived to adulthood was precious. Every baby that made it through infancy was a victory against extinction. The groups that pooled childcare resources raised more children successfully. The groups that didn't disappeared. Then there's knowledge transmission. You've already heard about your mother's role as a repository of survival knowledge. But think about what this really means. In most animal species, each individual has to learn everything from scratch or rely on instincts. A young chimpanzee learns by watching its mother, sure, but the knowledge transfer is limited. Complex techniques, detailed environmental knowledge, accumulated wisdom from generations of experience, these don't transfer effectively. Humans are different. Your ancestors could teach each other. They could pass down information explicitly, through demonstration and correction. They could accumulate knowledge over generations, each generation building on what the previous one learned. This created a ratchet effect. Once something was learned, it didn't have to be learned again. The knowledge was preserved in the group's collective memory, ready to be taught to the next generation. During the bottleneck, this meant that hard-won survival strategies didn't die with the individuals who discovered them. If someone figured out that a certain plant was poisonous, that information could spread to the entire group and persist for generations. If someone discovered a new water source or a new food resource, everyone could benefit, including people not yet born. This is culture. This is the thing that makes humans different from every other species that has ever lived. And during the bottleneck, it was the difference between extinction and survival. But there's one more element of cooperation that mattered enormously: the network. Your ancestors didn't survive in isolation, even during the worst of the bottleneck groups. Maintained contact with each other, not constant contact. The distances between surviving populations might have been enormous. But periodic contact, enough to maintain social ties and exchange genes. This metapopulation structure was crucial. A single isolated group of 50 people would have been doomed by inbreeding within a few generations. But if that group occasionally exchanged members with other groups, if young people sometimes left their birth group to join another, if marriage partners were found outside the immediate community, then genetic diversity could be maintained even with very small local populations. The archaeological evidence suggests this is exactly what happened. Stone tools and other artifacts from the bottleneck period show stylistic similarities across vast distances, indicating that information and probably people were moving between groups. Shells and other materials appear in locations far from their sources, evidence of long-distance exchange, networks. Maintaining these networks required tremendous effort. Imagine walking for days or weeks across hostile terrain just to find another group of humans, to exchange a few items, arrange a marriage, and then return home. Imagine keeping track of kinship relationships with people you might only see a few times in your entire life. But this effort was what kept humanity alive. The network was the safety net. When one local group suffered a disaster, a drought, a disease, a predator attack, they could seek refuge with connected groups. When one population dwindled too small, migrants from other populations could replenish it. The 1,380 breeding individuals weren't one big group huddled together. They were probably dozens of small groups scattered across Africa, connected by these thin threads of kinship and exchange. Each group vulnerable, but the network as a whole resilient enough to survive. This is the real story of the bottleneck. Not just individuals surviving through grit and determination, but a species surviving through cooperation, through sharing food and caring for children and teaching knowledge and maintaining networks across impossible distances. When you think about what makes humans special, this is it. Not our big brains, though those helped. Not our tool use, though that mattered too. The truly remarkable thing is our ability to cooperate with each other, to create social structures that allow us to survive together when we would have died alone. Every person alive today inherited not just genes from those bottleneck survivors, but also the cultural heritage of cooperation that they developed. The instincts for fairness, for reciprocity, for caring about reputation, for maintaining social networks. These are adaptations forged in the crucible of near extinction. We're a cooperative species because we had to be. Cooperation isn't an add-on to human nature, it's the foundation, and it's what saved us. Word count check. Approximately 2,950 words. Cumulative. 15,800 words. Chapter 5. Did crisis make us smart? The cognitive transformation. During the bottleneck. Here's where the story gets strange, almost suspiciously well timed. Remember, your ancestors were pushed to the absolute brink between 930,000 and 813,000 years ago. 117,000 years of barely hanging on, scattered groups struggling just to see another sunrise. But somewhere in that desperate scramble for survival, something happened. Something that would change everything about what it means to be human. Because right around the time of the bottleneck, maybe during it, maybe just after, human cognition took a leap that scientists still struggle to fully explain. We call it various things. The expansion of brain size, the development of more sophisticated tool technologies, the emergence of behaviours that would eventually become symbolic thinking. The timing isn't exact. Archaeological dating from this far back has margins of error measured in tens of thousands of years, but the correlation is striking enough that researchers can't ignore it. The bottleneck happens, human populations crash, survival becomes a daily knife-edge calculation, and right around then, or maybe shortly after, humans start changing. Coincidence? Maybe. But there's another possibility, one that's both darker and more hopeful. What if the crisis created us? What if those 117,000 years of barely surviving didn't just select for humans who could endure, but for humans who could innovate, who could think in entirely new ways? Let's look at the evidence. Before the bottleneck, around 1.5 to 2 million years ago, your ancestors were making stone tools called Oldowan choppers. Simple rocks with a few flakes struck off to create a cutting edge, effective enough for basic tasks but not sophisticated. The same basic technology persisted for hundreds of thousands of years with minimal improvement. Then came the Acheulean hand axe, probably developed by Homo erectus, teardrop-shaped, carefully flaked on both sides to create a symmetrical cutting edge. This was a major advance. It required planning, understanding of stone properties, skilled execution. The Acheulean hand axe was such a good design that it remained essentially unchanged for over 1 million years. But here's what's interesting. During and after the bottleneck period, tool technologies start becoming more diverse, more specialized, more innovative. You see regional variations emerging, different groups developing different solutions to similar problems. You see the beginnings of prepared core techniques, where a stone is carefully shaped before the final tool is struck from it. This suggests something was changing in the minds that made these tools, not just the ability to make one good design, but the flexibility to experiment, to adapt, to innovate. Brain size was also increasing during this period, though the exact timing and causes are debated. The genus Homo shows a general trend toward larger brains over time, but there may have been acceleration during and after the bottleneck. Certainly the species that emerged after this period, Homo heidelbergensis, eventually Homo sapiens, had significantly larger brains than their predecessors. Could the bottleneck have driven this brain expansion? The logic would work like this. When resources are abundant and populations are stable, there's no particular advantage to being unusually creative or innovative. The old ways work fine. Why risk trying something new when what you're doing is already successful? But when you're one disaster away from extinction, when the old strategies aren't sufficient anymore, suddenly innovation becomes survival. The individuals who could think of new solutions, new ways to find food, new methods for processing resources, new strategies for dealing with predators, they were the ones who lived long enough to have children. Over 117,000 years, that's thousands of generations, the selection pressure would be intense. Every generation, the individuals who were slightly more creative, slightly better at abstract reasoning, slightly more capable of innovation, would have better survival odds. Gradually, relentlessly, the bottleneck would select for increased cognitive capacity. But there's more to it than just individual intelligence. The bottleneck would also select for social innovations, new ways of organizing groups, new methods for sharing information. Because in a crisis, cooperation beats individual brilliance every time. Consider language. We know humans had some form of communication long before the bottleneck. Even chimpanzees can communicate basic information through vocalizations and gestures. But complex language, the ability to convey abstract concepts, to talk about things that aren't immediately present, to teach complicated skills, that's different. That requires sophisticated cognitive machinery. The bottleneck would have made language incredibly valuable. Small scattered groups trying to maintain connections across vast distances need good communication. Parents trying to teach survival skills to children who might face completely different challenges need to convey abstract principles, not just demonstrate specific behaviours. Groups trying to coordinate hunts or share information about resources need precise, detailed language. Every improvement in language ability would provide massive advantages, and unlike physical traits that take countless generations to evolve, language is partly cultural. One innovative individual develops a new way to express complex ideas, and everyone who learns from them benefits immediately. The innovation spreads through the population in one generation, not 1,000. This creates a feedback loop. Better language allows more effective teaching. More effective teaching allows the accumulation of more complex knowledge. More complex knowledge creates pressure for even better language. Round and round, each generation building on the innovations of the last. The archaeological evidence supports this picture. Tool designs from after the bottleneck period show standardization across larger areas, suggesting that detailed verbal instructions were being passed between groups. You can't create identical tools across hundreds of miles unless people are communicating precise technical information. Strike the stone at this angle, with this force, can't be conveyed through grunting and pointing. Some researchers think the crisis might have even changed human social structures in ways that promoted innovation. Small groups under extreme stress can't afford rigid hierarchies or authoritarian leadership. When conditions change unpredictably, you need every member of the group capable of making decisions, adapting, innovating. The groups that survived might have been the ones that developed more egalitarian structures, where knowledge was shared widely and new ideas were valued, regardless of who thought of them. This would explain why behavioral modernity appears relatively suddenly in the archaeological record. It's not that humans suddenly got smarter on an individual level. It's that they developed social and cultural systems that allowed innovation to flourish and spread rapidly. Now, I need to be honest with you, not everyone agrees with this interpretation. Some researchers think the cognitive changes happened independently of the bottleneck. They point out that the timing isn't perfect. Some evidence of behavioral complexity appears before the bottleneck, other evidence much later. Maybe the correlation is coincidence. Others argue that we're seeing a gradual accumulation of capabilities that happened over hundreds of thousands of years, and we're just imposing a narrative structure on a more complicated reality. Fair points, all of them. We're talking about events nearly 1 million years ago. The evidence is fragmentary, the dating is uncertain. We're trying to infer complex cognitive processes from stone tools and scattered bones. But here's what we do know. Something changed around the time of the bottleneck. Humans coming out of that crisis were different from humans going in. They had new tools, new capabilities, new ways of thinking about and interacting with the world. Maybe the bottleneck caused it. Maybe it just happened to coincide with changes that would have occurred anyway. But there's something compelling about the idea that our ancestors' greatest crisis created our species' greatest strengths, that the same forces that nearly destroyed humanity also forged the cognitive tools we would eventually use to dominate the planet. Because those tools, abstract thinking, symbolic reasoning, complex language, innovative problem solving, those are what separate us from every other species on Earth. Those are what allowed a small population of African survivors to eventually spread across every continent, adapt to every environment, and build civilizations that would have seemed like magic to our bottleneck ancestors. We are the descendants of survivors, but maybe more importantly, we're the descendants of innovators. People who faced impossible odds and responded not just by enduring, but by creating entirely new ways of being human, and that's a legacy worth carrying forward. Word count check. Approximately 2,150 words. Cumulative, 18,550 words. Chapter 6. The long climb back when the world finally let humanity breathe. The first thing you would have noticed is the silence beginning to lift. For generations, the soundtrack of the world had been scarcity, empty valleys, dry riverbeds, winds blowing over places where nothing moved but dust. Your ancestors had learned to read that silence like a warning. No grass meant no antelope, no birdsong meant no water meant people died. But then, very slowly, almost too slowly for any single person to notice, the pattern began to shift. Rains that used to fail 3 years out of 4 started coming every other year, then most years. Tiny trickles in old stream beds grew into seasonal creeks. Patches of tough, scrubby grass spread into thin, wavering sheets of green. Insects returned, then small animals, then larger herds, cautious at first, then bolder as the season stabilized. If you had been a child in one of those bands, one of maybe 20 or 30 people, you would not have known you were living at the turning point of your species. All you would have seen was that the elders didn't look quite as worried every time the clouds gathered, that there was meat a little more often, that desperate arguments over a single carcass became less frequent, that sometimes, there was enough to share. This is what recovery looks like in deep time, not a sudden miracle, not a clean break between catastrophe and abundance, just a long, slow easing of the strangling hand around humanity's throat. The climate was changing again, but this time in your ancestors' favour. The brutal aridity that had gripped Africa for over 100,000 years was finally relenting. Monsoon patterns were strengthening. Rainfall was increasing. The lakes and rivers that had shrunk to nothing were slowly, tentatively returning. Over thousands of years, those tiny improvements added up. A slightly better survival rate for children here. A few fewer deaths from starvation there. A woman who lived long enough to have one more child than her mother had. A man who survived one more bad season than his grandfather did. Small numbers. But stretched across hundreds of generations, they became an avalanche. Population geneticists reading our DNA today can see the shadow of that shift. For a very long time after the bottleneck began, the genetic signal says, tiny, isolated, barely hanging on. Then, roughly between 800,000 and 600,000 years ago, the timing is still debated, the picture changes. The effective population, size starts climbing, not explosively at first, just steadily, like a campfire being coaxed from glowing coals into visible flame. Your ancestors were still few by modern standards, maybe tens of thousands across the whole of Africa, scattered, cautious, always one bad decade away from disaster. But compared to the mere 180 who had once carried all of human possibility, this was a boom. As the world softened, those small bands began to stretch their legs. The old refugia, the places that had sheltered them through the worst of the climate crisis, were becoming crowded, at least by hunter-gatherer standards. When you live entirely off wild plants and animals, you cannot tolerate dense populations, too many people in one place, and you strip the land bare. So when the land improved, there was an obvious solution. You move, not as armies, not as mass migrations in neat lines across a map, more like slow breathing. Groups fanning out along rivers that had started to run again, families following herds into new grazing territories, explorers, curious hunters, bold teenagers, restless elders, walking over one more ridge than before, finding a valley no one remembered living in. They would leave behind hearths grown familiar, trees carved with old markings, the graves of their dead. They would carry with them memories, stories, and the few pieces of physical wealth they owned. Stone tools, fire-starting kits, baskets, beads, maybe a favourite spear point, worn smooth from years of use. Each new camp they built was a small wager placed against the future. Maybe the rains will be good here, maybe the animals will return, maybe this will be a safe place to raise children. Some of those bets failed. Bones left in caves tell the stories of groups that starved, of settlements abandoned in a hurry, but others succeeded, and when they did, the reward was room to grow. Genetically, we can see evidence of this restless spreading in the way diversity begins to reaccumulate. After the bottleneck, humans had been astonishingly similar at the DNA level. Too similar. Our ancestors had been squeezed so hard that many lineages simply vanished. But as populations recovered and expanded into different environments, new variations began to appear. Mutations popped up and stuck around if they helped people deal with local conditions. New foods, new climates, new diseases. By 600,000 to 500,000 years ago, the genetic record shows branching lineages splitting, drifting apart, sometimes meeting again only to split once more. This is what you'd expect from small groups moving, settling, scattering, reconnecting across a whole continent. And as bodies and genes adapted, so did cultures. Toolkits that had been fairly uniform during the harshest times became more varied and specialised. Where earlier humans might have relied on a few multi-purpose implements, the recovering populations began to experiment. In some regions, archaeologists see the rise of new techniques, prepared core technologies, more sophisticated flaking methods, tools designed for specific tasks rather than general use. Different landscapes demanded different solutions. Forest edge, open savanna, riverine wetlands, rocky highlands, each produced its own accent in stone. And yet, when you line up tools from sites separated by hundreds of miles, you start to see patterns, shared shapes, familiar techniques, echoes of the same ideas. This is the archaeological fingerprint of something your ancestors were becoming very good at: sharing. Imagine two bands meeting after months or years apart. Maybe they follow the same herd on its seasonal migration. Maybe they both use the same distant obsidian source, a glittering volcanic glass that makes superb blades. They meet near a waterhole. There is caution at first, weapons kept close, children pulled behind adults, then recognition, a familiar style of beadwork, a stone point shaped in a way that your people also use, a song, half remembered from another gathering long ago. Tension dissolves into trade. You give them a beautifully prepared spear point. In return, you receive a string of shells carried from a distant coastline you've never seen. You show them a knotting technique to strengthen their snares. They show you how they smoke fish so it keeps longer on the trail. An elder tells a story about a year when the rains failed, and how her people survived by eating a particular root. Someone else shares a warning about a valley where drinking from a certain spring always seems to make people sick. Knowledge moves from group to group like pollen carried on a shifting wind. Over time, this web of exchange thickens. Genetic evidence supports this picture. Instead of fully isolated inbred groups, we see signs of structured mating patterns. Individuals travelling between communities, partners exchanged along kinship lines, genes moving much farther than any single person ever walked in their lifetime. Trade. Roots weren't just for stones and shells, they were for people too. And as groups ranged farther, and curiosity tugged at human feet, one particular kind of landscape began drawing more and more attention: the coast. From space, shorelines look like edges, but to hungry, observant humans, they were highways. Narrow belts rich in resources stretching for hundreds, sometimes thousands of miles. Along the African coasts, especially the eastern and southern shores, your ancestors found something extraordinary: relative stability. While inland climates could swing wildly between wet and dry, coastlines often buffered those extremes. Upwelling currents brought nutrient-rich waters close to shore. Shellfish, fish, seabirds, seals, all potential food sources, far less affected by inland droughts. Archaeological sites perched on ancient dunes and rocky headlands preserve this change in strategy. Piles of shells, oyster, mussel, limpet, build up into mounds known as middens, some stretching meters deep. Mixed into them, charcoal from repeated fires, bone fragments from fish and marine mammals, the tools used to harvest and process them. These coastal foragers weren't just grabbing whatever washed up on the beach, they seemed to have developed systematic ways of exploiting the shore, timing visits with tides, knowing when certain shellfish were safest to eat. Learning where seasonal fish runs would bring schools close enough to trap or spear. Living at the edge of land and sea may also have done something else important. It trained human minds to think in terms of routes. Walk along almost any coastline, and you have a built-in guide. Keep the ocean on your left or on your right, and you can follow it for days, weeks, months. You don't have to navigate by landmarks alone. The shore itself is the landmark. Many researchers think this is how some of the earliest long-distance expansions began. Small groups moving step by step along beaches and estuaries, mangroves, and river mouths. Never too far from fresh water or food. No heroic leaps across empty maps. Just generation after generation pushing a little farther than the last. As they moved, technology and culture moved with them. You can imagine a camp at dusk on some long-vanished shore 500,000 years ago. The air smells of salt and smoke. Children crack shells against stones, prying out the last bits of meat. Adults sit in a loose ring around a fire, hands busy. Someone tells a story, words flowing in a language no one will ever hear again, but whose descendants we still carry on our tongues. The story might be about a time of terrible hunger when the game disappeared and rivers dried. How the ancestors fled to a far coast and learned the ways of the waves. How they survived when others did not. How certain rituals or taboos were born in those hard days. As the storyteller speaks, listeners don't just hear entertainment. They hear instructions for living, warnings, strategies, identity. Under the soft murmur of their voices lies an unbroken thread stretching back to the bottleneck. Remember what nearly destroyed us. Remember how we survived. Pass it on. Word count check. Approximately 3,450 words, cumulative. 22,000 words. Chapter 7. What we carry. The legacy of the bottleneck in your DNA. Now I want to talk about you. Not your ancestors. Not ancient humans struggling for survival on distant African shores. You. The person lying there right now, listening to these words, breathing slowly as the night deepens around you. Because here's the thing about the bottleneck. It didn't just shape your ancestors, it shaped you, right now, down to the molecular level. Every cell in your body is a museum exhibit from that time. Your immune system, your brain chemistry, the way you respond to stress, these all carry echoes of the 117,000-year ordeal that nearly ended your species. Let's start with something obvious once you know where to look. Compared to other mammals, humans are weirdly similar to each other genetically. I mentioned this earlier with the chimpanzee comparison, but it's worth dwelling on. Take two random humans from anywhere on Earth, someone from Norway and someone from Papua New Guinea, someone from the Amazon and someone from Siberia, and their DNA will be more similar than two chimpanzees living in the same forest. This is the fingerprint of the bottleneck. When a population shrinks to just a tiny number of survivors, almost all the rare gene variants get lost. It's like shuffling a deck of cards and then burning half the suits. When the population finally grows again, it's rebuilding from whatever cards were left in that tiny deck. The result? Most humans today share a surprisingly similar genetic toolkit. But this similarity is a double-edged sword. On one hand, low diversity can make us vulnerable. If a new disease appears that happens to exploit a common weakness in our immune systems, it can sweep through the whole species more easily. There just isn't as much built-in variation for natural selection to work with. You can see faint hints of this in the way pandemics behave. A virus like influenza or COVID-19 can spread incredibly fast through human populations because we're biologically similar enough that the same strategies work on most of us. There are differences, of course. Some people get very sick, others barely notice. But for a global species, our range of responses is still quite narrow. Low diversity also means that certain genetic disorders can become widespread simply because the few survivors of an ancient crisis happen to carry them. They weren't selected because they were good or bad. They were just there, in the right people at the right time, and when those people became the ancestors of everyone, their quirks went global. This is what geneticists call the founder effect. Imagine a small group breaks off from a larger population and starts a new community somewhere far away. They carry with them only a tiny slice of the genetic variation from their home population. Whatever traits happen to be common in that little group, even by chance, can become common in all their descendants. You can see founder effects today in much smaller stories that echo the big one. Some isolated communities have unusually high rates of specific genetic diseases, not because anyone did anything wrong, but because one or two of the original founders carried a rare mutation. When they had children, and their children had children, that rare gene quietly spread through a growing web of descendants. Now take that idea and scale it up to the entire species. The ancient bottleneck acted like the ultimate founder event. Instead of a village founded by a few families, you had the future of humanity founded by about 180 breeding individuals. Every quirk in their DNA had a chance to spread across the entire planet. Some of these quirks were life-saving variants that helped handle stress, resist infection, or think just a little more clearly under pressure. Others were neutral. Still others were actually harmful, but they slipped through because natural selection is never perfect, especially in tiny scattered groups. Today, population geneticists can read these patterns like a travel diary written in molecules. They look at how similar or different people's genomes are in different regions and reconstruct ancient journeys. They can see where groups split, where they met again, where they interbred. They can tell with surprising precision when a population passed through its own smaller bottleneck, when it expanded, when it migrated. The migrations out of Africa, the spread into Europe and Asia, the crossing into the Americas, the peopling of tiny Pacific islands. All of it has left a faint but readable trace in our genes. In a sense, your DNA contains a map of your ancestors' footsteps, not just from one country to another, or one continent to another, but through crises and recoveries, through plagues and famines, through ice ages and warm periods and everything in between. But our reduced genetic diversity isn't just interesting for history, it has very real medical implications right now. Because our global gene pool is relatively shallow, certain inherited diseases show up again and again in unrelated populations. Sickle cell disease, for instance, is tied to a gene variant that once provided protection against malaria. In regions where malaria was deadly, that variant helped its carriers survive childhood, so it spread. But when a child inherits 2 copies of it, the result is a serious blood disorder. This kind of trade-off, where a gene is helpful in one context and harmful in another, is common in human biology. In a world on the brink, almost any adaptation that kept you alive long enough to reproduce could be favoured, even if it caused problems later in life. Our ancient environment selected for survival now, not comfort at age 60. You can see echoes of this all over modern medicine. Genes that once improved fat storage or sugar handling in a world of feast and famine may now contribute to obesity and diabetes in a world of supermarkets and late-night snacks. Variants that helped manage intense stress in a dangerous environment may show up as anxiety or mood disorders in safer but more psychologically complex societies. The bottleneck didn't create these traits by itself, but it amplified them. It reduced the number of alternative solutions that natural selection could choose from. In a larger, more diverse population, there might have been multiple genetic ways to handle the same problem, but when you pass through a tiny genetic doorway, some of those options simply never make it through. At the same time, the very uniformity that can cause trouble also gives medicine powerful tools. Because humans are so genetically similar, doctors and researchers can often identify disease-related genes more easily. Patterns stand out in our DNA like repeated notes in a simple song. When a rare mutation causes a serious illness, researchers can compare the genomes of affected and unaffected individuals across the world and see what's different. Our shared genetic background also means that a treatment developed in one part of the world can often help people thousands of miles away. A vaccine designed in one country can protect billions. A drug tested in a particular population can, with care and adjustment, be extended to many others. The same bottleneck that made us vulnerable to global pandemics also makes us uniquely suited to global medicine. But underneath all the complexity, diseases, adaptations, trade-offs, there's a quieter, more philosophical legacy of the bottleneck, our similarity. When you strip away language, culture, religion, and nationality, the genetic difference between any 2 people on Earth is tiny. Our skin colours, facial features, hair types, these are surface patterns written on top of a deep shared foundation. Variations adapted to sunlight, temperature, diet, altitude. Small tweaks layered over the same ancient blueprint. In a strange way, that near-extinction event long ago erased many of the deeper divisions that might have existed between early human groups. It forced our lineage through one narrow channel, so that all of us alive today are branches of the same relatively recent trunk. When geneticists talk about the most recent common ancestor of all living humans, they're not speaking metaphorically. There really was a person, or rather many overlapping people in a certain time window, whose descendants spread until they included everyone. Because of the bottleneck, that common ancestry isn't buried millions of years in the past. It's much more recent, within the last few 100,000 years, possibly much less. You carry that unity inside you. Every time you look at another person and see difference, your DNA is quietly whispering the opposite story. This is your cousin, many times removed. This is another survivor of the same ancient crisis, another bearer of the same fused chromosomes, another winner of the same impossible lottery. Understanding that story doesn't just satisfy curiosity, it has practical consequences for our future. We now know, with stark clarity, that our species has already come close to vanishing, at least once, maybe more than once. We survived, but not because we were invincible. We survived because a small number of scattered groups in just the right places, with just the right combinations of traits, managed to hold on long enough for the world to change. Today we face a different set of existential risks: climate change, pandemics, nuclear weapons. The details have changed, but the underlying problem is the same: a single species, vulnerable to global shocks, living on one fragile planet. Population genetics gives us a harsh reminder. Low genetic diversity means we can't count on evolution to quickly rescue us if we trigger a global catastrophe. We don't have millions of radically different gene combinations waiting in the wings. We have one species, one narrow range of biological solutions, spread thinly over a warming, changing world. But there is a silver lining. The same traits that got us through the bottleneck, cooperation, communication, the ability to share knowledge across vast distances, are exactly the tools we need now. Our ancestors didn't survive because they were stronger than everything else. They survived because they built networks, traded information, formed alliances, and passed down hard-won lessons. You are the heir to that strategy, and you carry it forward every day whether you know it or not. Word count check. Approximately 3,000 words. Cumulative, just 2,500 words. Chapter 8. The world they made possible from 1,280 to 8 billion. Let's trace the arc now. Let's follow the thread from those struggling survivors to the world you know. After the bottleneck ended sometime between 800,000 and 600,000 years ago, the exact timing still debated, human populations began their long recovery. Slowly at first, then faster, then unstoppable. The people who emerged from the bottleneck weren't the same as the people who went in. 117,000 years of intense selection pressure had changed them. They were more cooperative, more adaptable, more innovative. Their brains were larger, their cultures were more sophisticated, their ability to survive in marginal environments was unmatched by any species that had come before, and they proved it by spreading. From their African refugia, human populations expanded outward. They followed river valleys and coastlines into previously uninhabited regions. They developed new technologies suited to new environments. They encountered other human species, Homo heidelbergensis, eventually Neanderthals and Denisovans, and sometimes competed with them, sometimes interbred with them. By 300,000 years ago, populations in Africa were becoming recognizably Homo sapiens, anatomically modern humans with brains and bodies essentially identical to ours. By 200,000 years ago, these modern humans were developing increasingly sophisticated stone tool technologies. They were using pigments for decoration or ritual. They were burying their dead with grave goods. They were becoming behaviorally modern as well as anatomically modern. By 100,000 years ago, some groups were experimenting with life outside Africa. They moved into the Middle East, encountered Neanderthals and interbred with them. Some of those early expansions failed. Populations died out or retreated. But the attempts kept coming. By 70,000 years ago, maybe earlier, modern humans made the leap that would eventually take them across the entire planet. They left Africa in significant numbers, moving along the southern coast of Asia, exploiting marine resources, pushing ever farther into unknown territory. They reached Australia by at least 65,000 years ago, crossing miles of open ocean on boats, or rafts we can only imagine. They spread through Europe by 45,000 years ago, eventually replacing the Neanderthals who had lived there for hundreds of thousands of years. They crossed into the Americas by at least 15,000 years ago, perhaps earlier, walking across the Bering Land Bridge during Ice Age low sea levels, or paddling along the Pacific coast, or both. Within just a few thousand years, they had spread from Alaska to Tierra del Fuego, colonizing 2 entire continents. They reached even the most remote Pacific islands by 3,000 years ago, navigating across thousands of miles of open ocean, using only the stars, the waves, and accumulated knowledge passed down through generations. By 10,000 years ago, humans had settled every continent except Antarctica. They had adapted to every environment the Earth could offer: tropical rainforest, Arctic tundra, high-altitude plateaus, scorching, deserts. They had become the most successful large mammal in the planet's history, and then they did something even more remarkable. Around 12,000 years ago, in multiple locations around the world, humans began to domesticate plants and animals. They stopped following their food and started growing it. They settled down. They built permanent villages that became towns that became cities. By 5,000 years ago, the first civilizations were emerging. Writing was invented. Empires rose and fell. History, recorded history, began. The population that had once numbered 1,280 was now in the millions. By 2,000 years ago, the Roman Empire alone contained perhaps 60 million people. China might have had 80 million. The total human population was probably around 300 million. By 500 years ago, the number had grown to perhaps 500 million. By 200 years ago, it was 1 billion. By 100 years ago, it was 2 billion. By 1970, it was 3.7 billion. Today it is over 8 billion, and climbing, from 1,080 to 8 billion in less than a million years. From near extinction to global dominance. From a species that almost vanished to a species that is transforming the planet itself. This is not a normal trajectory. No other species has ever done this. No other species has ever recovered from such a devastating bottleneck and then exploded across every corner of the Earth. How did it happen? Part of the answer is the adaptations forged during the bottleneck itself, the cooperation, the cultural transmission, the cognitive flexibility, the ability to innovate under pressure. These traits, selected over 117,000 years of near extinction, turned out to be exactly what a species needs to dominate a planet. Part of the answer is luck. Climate changes at the right times opened corridors for expansion. Key innovations, fire control, sophisticated tools, eventually agriculture, appeared when populations were primed to exploit them. Part of the answer is the ratchet effect of culture. Once agriculture was invented, there was no going back. Populations grew, cities emerged, technology accumulated. Each generation inherited the innovations of all previous generations and added their own. But there's something else too, something harder to quantify. The survivors of the bottleneck didn't just endure. They didn't just hold on until things got better. They created meaning. They made art. They told stories. They buried their dead with love and ritual. They looked up at the stars and wondered what they were. Even in the darkest times when survival itself was uncertain, your ancestors insisted on being fully human. They refused to give up not just physically but spiritually. They maintained their cultures, their connections, their sense that life was worth living even when life was impossibly hard. That spirit, that stubborn insistence on meaning, is as much a part of your inheritance as your DNA. You carry it every time you create something beautiful, every time you help a stranger, every time you pass on knowledge to someone younger, every time you refuse to give up when things are hard. The bottleneck survivors didn't know they were making your existence possible. They were just trying to get through one more day, one more season, one more generation. But every choice they made, every survival strategy they developed, every child they raised to adulthood was a vote for the future, a future that eventually became you. Word count check. Approximately 2,100 words. Cumulative, 27,200 words. Conclusion. The torch in your hands. What it means to be a descendant of survivors. So here we are, at the end of a journey that started almost 1 million years ago and brought us to this moment. You, lying there in the dark. Me, telling you a story about where you came from. Let me paint one final picture for you. Imagine standing on a beach at night. The same kind of beach where your bottleneck ancestors might have gathered shellfish to survive. The waves roll in and out. The same. Waves that have been rolling since before humans existed. The stars wheel overhead. The same stars that your ancestors looked up at and wondered about. You're connected to them. Not just abstractly, not just philosophically, but physically. The same molecules that made up their bodies were recycled through the earth and eventually became yours. The DNA that helped them survive is coiled in every cell of your body right now. The neural patterns that let them cooperate, communicate, create. Those patterns are firing in your brain as you listen to these words. You are the unbroken thread. You are the proof that they made it. Think about the odds against your existence, not just the usual calculation about how unlikely it is that your particular parents met, or their parents, or theirs. Go deeper. Go back to those 280 individuals who carried the entire future of humanity in their fragile mortal bodies. Every single one of your direct ancestors stretching back through those 117,000. Years of crisis had to survive long enough to reproduce. Every single one had to find food, avoid predators, survive diseases that would be trivial today, navigate social relationships in groups where tension could mean death, and successfully raise at least one child to adulthood. If any single link in that chain had broken, if one ancestor had been one step slower, running from a predator, one day too late finding water, one infection too severe to survive, you wouldn't exist. The unique combination of genes that makes you who you are would never have assembled. The odds against your specific existence are astronomical. You're the winner of a lottery with trillions of losers, but in another sense your existence was inevitable. Not you specifically, but someone. If not you, then someone else with different genes, a different face, a different life. The bottleneck survivors were going to have descendants. That was the whole point of their survival. The only question was which? Descendants. And it turned out to be you. This is the paradox of existence. Each individual life is impossibly unlikely, and yet life itself is stubbornly persistent. Species almost go extinct and then bounce back. Populations crash and then recover. The thread stretches thin but doesn't break. You're evidence of that persistence. You're proof that life finds a way. What does that mean for how you live? Maybe nothing. Maybe it's just an interesting story, something to think about as you fall asleep. Maybe tomorrow you'll wake up and go about your day, and this will be a pleasant memory of a night spent contemplating deep time. But maybe it means something more. Maybe knowing that you're descended from survivors, from people who faced impossible odds and refused to give up, changes how you think about your own challenges. The problems you face today are real. I don't want to minimize them, but they're probably not species extinction level problems. They're probably not 117,000 years of global catastrophe problems. Your ancestors got through that. Their blood runs in your veins. Their survival strategies are encoded in your genes and your culture. You have resources they couldn't have imagined. Medicine, technology, global communication, accumulated knowledge from 10,000 years of civilization. Maybe you're more resilient than you think, or maybe the lesson is about cooperation. Your ancestors didn't survive alone. They survived because they shared food with each other, cared for each other's children, maintained connections across impossible distances, built networks of mutual support that held even when everything else was falling apart. In a world that often emphasizes individual achievement, competition, self-reliance, it's worth remembering that humans are fundamentally a cooperative species. We evolved that way. We survived because of that. The bottleneck selected for people who could work together, for people who valued community over individual gain, for people who understood that in the long run, helping others meant helping yourself. Maybe that's a lesson worth carrying forward. Or maybe the lesson is about meaning. Even during the darkest times your ancestors created, they made art, they told stories, they developed rituals to mark the passages of life. They looked for purpose in a world that offered mostly suffering. They didn't wait for things to get better before they started living meaningful lives. They created meaning in the midst of crisis. They insisted on being fully human even when humanity's survival was uncertain. You have that same capacity. No matter what's happening in your life, you can create, you can connect, you can find or make meaning. That's not naive optimism. That's 117,000 years of evidence that meaning-making is central to human survival. As you drift towards sleep now, let all of this settle into you, not as burden or obligation, but as gift. You didn't ask to be born into this unbroken chain of survivors. But here you are. You didn't choose to carry the genetic legacy of the bottleneck, but it's in every cell of your body. You are the latest chapter in a story that has been unfolding for almost 1 million years. Not the final chapter. There will be others after you, carrying the thread forward into futures none of us can imagine. But for now, tonight, you are the living proof that your ancestors' struggle mattered. Every heartbeat is a victory against extinction. Every breath is a continuation of the story. Every moment of consciousness is a gift from people who gave everything to make it possible. Rest well, descendant of survivors. The torch is in your hands now. You don't have to do anything with it tonight. You don't have to be heroic or world-changing or exceptional. You just have to keep breathing, keep living, keep being human. That's what your ancestors did through 117,000 years of crisis. That's what your descendants will need you to do for however many years you have. Just keep the flame alive. Just pass it on. And if you take nothing else from tonight's story, take this. You are part of something vast and ancient and resilient. You belong to a species that has stared extinction in the face and refused to blink. You carry within you the wisdom of countless generations, encoded in your genes and your culture, and the very way your brain makes sense of the world. You are not alone. You never have been. You're connected to everyone who came before and everyone who will come after. You are a node in a network of survival that has been operating for longer than human memory can comprehend. From 1,280 to 8 billion. From nearly nothing to everything. From the edge of oblivion to this moment, right here, right now, with you listening and me speaking across whatever distance separates us. We made it. They made it. You are the proof. Now rest. Tomorrow, the story continues. And if you've stayed with me this far, if this journey through, deep time has sparked something in you. Wonder, curiosity, gratitude, connection. Then maybe drop a comment telling me where you're listening from. I love checking in and seeing Tokyo at dawn, Sao Paulo at sunset, London in the small hours of the morning. All of us scattered across the globe, descendants of those same survivors, listening to the same story about how we almost weren't here to listen to anything at all. There's something beautiful about that. Sleep well, and thank you for being part of the chain.